So today we're going to start chapter 3 and we're going to cover part of section 1. We will not get through all of the examples in these notes. So the first thing we're going to see is what a graph of a quadratic equation or a quadratic function looks like. Now, in our textbook, they call this format ax squared plus bx plus c. They call this quadratic form. In other textbooks, they actually refer to it as standard form. So just be aware that in our book, we're going to be referring to the ax squared plus bx plus c format of the quadratic equation or function as the standard form. What they're going to refer to as standard form is going to be on the next couple slides ahead, and that's going to be f of x is equal to a x minus h squared plus k. In other textbooks, this is called vertex form, or maybe even on the SAT. So be aware of the names of the functions. For our book, we're referring to this as the quadratic form, okay? But again, in other textbooks, they may call this one standard and then this one vertex. So just be aware of that. All right, so the graph, or the name that they give the shape of this quadratic function, is called a parabola. Now, you've probably covered some of this in your Algebra 1 class. So again, we're going to review it. So the graph takes on a U shape. And when the number that is in front of x squared, this a value, when a is a positive number, think of a positive person and they're always smiling, so your graph opens upward. When your a value is going to be a negative number, a negative person is not a happy person, they're frowning all the time, so your graph would be the reflection. It would be flipped upside down. Also, the different parts of your graph, the point where your graph changes direction. So in this graph that's here, this blue U, notice this side of the graph is decreasing, but this side is increasing. So the point where your graph changes direction from increasing to decreasing or decreasing to increasing is called the vertex. It's an order pair. Now coming up, and here notice they have the letters HK. Remember, an order pair is XY, but because in their standard form, you don't want to put x minus x, they call the vertex HK. The vertex, when it's a U shape, is always the lowest value that the graph will have, and it's the Y value. So this order pair for this vertex is actually the order pair -1, 0. So the lowest Y value that this graph has, the minimum value, is 0. When your graph and your A value is negative, then your graph looks like an upside down U, and this vertex point would be a maximum. This is the highest it can get. Also through this vertex is this imaginary line, or it is a line, it's called the Axis of Symmetry. So it's like a line of symmetry that if you were to draw a vertical line through that vertex, that would be your line of symmetry for your parabola, and you could fold it up and everything would match perfectly. This axis of symmetry is an equation because it's a vertical line. And the equation that it takes on is just x equals that number that's in your vertex. It's the x of the vertex, and it's x equals, because it's a vertical line. So So these are the parts of the parabola. Now you're going to be given a function or be given an equation, and they're going to ask you to find the vertex, to find the Y-intercept, to find X-intercepts, and to find the axis of symmetry. So let's go ahead and see how we can find the vertex given an equation or a function. These are the steps you will follow to graph an equation when it's in the quadratic form. Again, in our book, quadratic form means ax squared plus bx plus c, and they would have f of x equals. To find the vertex, you're going to take the b value, make it opposite sign, and divide it by 2 times a. This will give you the x of your vertex. Then you're going to take that x and then you're going to plug it back in to the equation to get y. Because again, remember, f of x is really y. It's the same thing as saying y equals. The next point you will graph will be the y-intercept. When your equation is in this form, ax squared plus bx plus c, your y-intercept is staring at you right here. It's your c value. It's the constant. So if you were to turn this into an ordered pair, it would be 0, comma, whatever the number for c is. And we're going to see this in examples in a minute. Next, you would need to graph some additional points. The easiest way is to use that axis of symmetry to get a third point to make the other side of your parabola. You can also use X-intercepts. The problem with using the X-intercepts, sometimes my X-intercepts are going to involve radicals. And if you're not using a calculator, you would have to approximate their value. So let's try to graph a quadratic equation. But before we start using this method, let's just relate these quadratics to our parents. So if you remember, the parent function for the quadratic equation is, and we can call this with a different letter, I could say it's g of x. Remember, the parent is the x squared, and the order pairs for the parent would be -1, +1, 0, 0, 1, 1. So remember, the graph looked like this, and you had to memorize that it took on a U shape. And if you just relate it to the stretches, the 2 in front of the x squared, this indicated that this was a vertical stretch because it was greater than 1. On this equation, this is going to be a vertical shrink. So if I wanted to graph now this one, remember the 2 means that it goes up 2 times as fast. So this is just how it's relating back to what we've already done when we graphed the parents and we applied the shifts. Now, if you notice on all of these, the red ones that we just graphed, notice my vertex is at the order pair 0, 0. So is my y-intercept, and so is my x-intercept. And again, if you didn't know how to graph it and you wanted to plug in zeros, you could do that also. So just to demonstrate, if you wanted to find the vertex using the formula -b over 2 times a, in this equation, the a is 2, so if it's in the f of x equals 2x squared, I don't have a b and I don't have a c. All I have is the a. So -0 over 2 times 2, 0 divided by anything is 0. So x equals 0. And then when you plug it back in, you still get 0. Because 2 times 0 squared is 0. So my vertex is 0, 0. If I were to plug in to find the x-intercept, I would set y equal to 0. So 0 equals 2x squared. Divide by 2. 0 equals x squared. Square root it. And x equals 0. So my y-intercept, if you didn't catch it, you plug in the 0 and you still get 0. Same thing for the y-intercept. Plug in 0 for x. So y equals 2 times 0 squared. 2 times 0 is just 0. So your y-intercept is also 0, 0. You're not going to be asked to do anything like this simple. This is better by applying the shifts. Yes. Reflection. Remember, whenever there's a negative in front, this means that it's a reflection across the x-axis. And then this 4 means it goes up 4 times as fast. So again, your parent would have been the 0, 0, the negative 1, 1, and then the 1, 1. If you reflect it first, then it comes down here. Let me get rid of the original guys here. And then now 4 times as fast. Really, the ordered pairs you're going to graph are negative 1, negative 4, 0, 0, positive 1, negative 4. Yes. Yes. So then here, 1, 2, 3, 1, 2, 3, 4. And then notice it went and got skinnier because it went, instead of going to 1, 1, or 1, negative 1, and negative 1, negative 1, now it's at negative 1, negative 4. Same thing on this one. It's going to go 1/4 as fast, so it's going to be shorter. So here again, it's a reflection. And then it would be over here, and it would be wider. So 1/4 as fast. Again, this is just tying it back into the parents and how we shift. Now let's look at the standard form and how we can graph from this form. So this is the standard form. So again, the h and the k in the equation together become your vertex. The h comes out with an opposite sign. So it's backwards of what you would think. So for example, if you had f of x is equal to x minus 2 squared plus 5, the vertex that went in here, just the 2, because the subtraction is part of the equation, but the 5 is the sign that is there. So the vertex here is going to be 2, 5. However, if your function had f of x equals x plus 4 squared minus 1, then your vertex here, what went in here was negative 4 and negative 1. So this is backwards of the sign that's there. The k is always the sign that you see. We're going to be translating quadratic form into this standard form by completing the square. Try some examples. So here is an equation or a function, and it's given to us in their standard form. First thing I want to do is find the vertex. The vertex is here at hk. Again, the h comes out with an opposite sign, but the k has the sign that's right there. So that is your vertex. Now, because this is not in the quadratic form, I've got to work for the y-intercept. That negative 3 is not my y-intercept. It's not the c. So to find my y-intercept, I'm going to set x equal to 0. So what I do is I'm going to take f of x, I'm going to say instead y equals 0 plus 2 squared minus 3. 0 plus 2 is 2. 2 squared is 4. So the y-intercept is the order pair 0, 1. Because I plugged in 0 and then I got y equal to 1. So I'm going to graph that. I'm going to graph my vertex. And I'm also going to graph my axis of symmetry. And remember, your axis of symmetry is the x equals that x of the vertex. So I'm also going to graph this. This is enough information for me to get the shape of my parabola. Now I am going to go back and also find my x-intercepts because you will be asked to list those as well. So let's graph the vertex. It's the order pair -2, -3. So I'm going to come over here to -2, -3, and put a point. Next, I'm going to graph my y-intercept, which is the order pair 0, 1. I'm also going to put in my axis of symmetry, which is this vertical line that goes through that red vertex. Think of it like a line of symmetry that's splitting my parabola in half. So I've already got the right side of my parabola. Now let me get my left side in here. And there's the graph of your parabola.
How did you do the left side?
Oh, okay. So I need to count how many spaces away. Let me erase that. Okay, so for this one, what I'm going to do is I'm going to see how many spaces away from that green line is my y-intercept. You see how it's 2 boxes away? Then I can come over here and count 2 boxes just horizontally across and put my left side. I can use that line of symmetry to get my third point. Now I can connect my points and make my parabola. Now I'm going to calculate my x-intercepts. Now, when it's in this standard form or this vertex form, to find the x-intercepts is easier. So again, to find the x-intercept, you set y equal to 0. So I'm going to do 0 equals x plus 2 squared minus 3. I'm now going to use the square root method to solve this. I'm going to add 3. 3 equals x plus 2 squared. And now square root both sides. And now I'm left with plus and minus the square root of 3 equals x plus 2. I need to isolate x, so I move the 2. And now I get -2 plus or minus the square root of 3 equals x. I'm going to turn these into coordinates. So it's -2 minus the square root of 3, 0, and -2 plus the square root of 3, 0. Chances are it's not going to ask you to graph them, but they will ask you to list them. Now, just to confirm that when I just put those 3 points on my graph to see how close my x-intercepts actually came, let's try and do this. So I'm going to approximate the square root of 3 to be about 1.7. So if I do -2 minus 1.7, I end up trying to graph the order pair negative 3.7, comma 0. And then over here, if I do negative 2 plus 1.7, I end up with negative 0.3, comma 0. So let's see how close we came. So negative 3.7 should be in between 3 and 4. Maybe it's a little off, but it's not too bad. Negative 3.7, comma 0 is this point right here. And then the other one was negative 0.3, comma 0, which is right here. So I did pretty good just by graphing the vertex, the Y-intercept, putting in that axis of symmetry to get the other side, and then connect those 3 points. Yes?
But it's like not exact, it's not like points off or anything.
Right. What I'm looking for is the exact points that you did plot, the vertex and the Y-intercept, but as far as hitting the x-axis, no. But I will ask you to write down what the x-intercepts are in simplest radical form. So there would probably be a blank line where you would put this on the line. Everybody good? All right, so this is given to me in that quadratic form. I'm going to look for my y-intercept, my vertex, and my axis of symmetry. I'm going to look for those three things first. My y-intercept is the easiest thing to find. Remember, it's this c value, because remember, this is ax squared plus bx plus c. So my y-intercept is the order pair 0, negative 4. And remember, to find that, you're setting x equal to 0. So really what I did here was plug in zeros here and then solve. And again, these all cancel out, and you're just left with the negative 4. Now to find the vertex, this is where I'm going to use that negative b over 2a. So let me go ahead and do that. So for the vertex, I'm using x equals negative b, or opposite of b, over 2 times a. So my b value is negative 6, so opposite of negative 6 is positive 6. And then 2 times 1, 6 over 2, and it gives me 3. So the x value of my vertex is positive 3, which is also my h. Now to find y, now we have to find the y of the vertex. So we're going to plug in x equals 3 to our original problem. So we're going to do y equals 3 squared minus 6 times 3 minus 4. 3 squared is 9. 6 times 3, 18. And then minus 4. Work left to right. Negative 9 minus 4. And y equals negative 13. So this is the y of your vertex. So now I have this order pair to graph. I have my y-intercept to graph. And I also can get my axis of symmetry. Remember your axis of symmetry, you're going to use the x of the vertex, and it's x equals 3. It's that vertical line through the vertex. So let's get these pieces of information on here. Let's graph your y-intercept. 0, negative. I'm going to make my graph go by 2s so I can get 13 to fit. So this will be negative 2, 6, 8, 10, 12, 14, 2, 4. So I'm going to graph first my y-intercept, which is here. Let me do it in blue. So I'm graphing the order pair 0, negative 4. And then I'm going to graph the vertex, which is 3, negative 13. I'm going to draw in my line of symmetry. And now to get the other side, I'm going to go, see how this is 1.5 spaces away? I can go 1.5 spaces away and put my third point right there. So now let me connect those and make my graph. And now let's find the x-intercepts. Now, for this problem, when you find the x-intercepts, when it's in this quadratic form, remember to get x-intercepts, we set y equal to 0. So we're doing 0 equals x squared minus 6x minus 4. Now, to find x-intercepts, when it's in this quadratic form, you can either factor it, you can do quadratic formula, completing the square. I cannot factor this. There aren't any factors of -4 that give me -6. So I'm going to do quadratic formula because I'm also going to do this with completing the square. So I want to show you both options. So let's do quadratic formula. Your quadratic formula is -b plus or minus b squared minus 4ac all divided by 2 times a. So let me go ahead and plug in. My a value is 1, my b value is -6, and c is -4. So I'm going to plug in. So opposite of b, so +6, -6 squared, minus 4 times a times c, all divided by 2 times a. So 6 plus or minus 36 plus 16 over 2 times 1, which is 2. Do not be tempted to simplify yet. We need to simplify the radical first. So 36 plus 16 is 52. I need to break down the 52. I could do 4 times 13, which is 2 square root 13. So 6 plus and minus 2 square root 13 over 2. Now I can simplify the fraction, and I can divide them all by 2's. Make this a 1, make this a 1, make this a 3. So the x-intercepts are going to occur at 3 plus square root 13 and 3 minus square root 13. So listed as coordinates, 3 minus the square root of 13, comma 0, and 3 plus the square root of 13, comma 0. These are your x-intercepts. Let's see how well we did. The square root of 13 is approximately equal to about 3.6. So if I do 3 minus 3.6, this gives me -0.6, comma 0. And then over here, 3 plus 3.6. This up, so then this becomes really 6.6, comma 0. So let's see how close we came. Remember, my graph went by 2's. So 6.6, it's going to be, again, this would be a 6, this would be an 8. So this is probably pretty close. So here is 6.6, comma 0. And then this one is supposed to be the -0.6, comma 0. So it's pretty close to it. So that's how you could graph it. You would label your x-intercepts not as decimals. You would label it, if it asked to label it on the graph, you would label it using the simplest radical form. Now let me do completing the square on this one. Same question. Let's change it into vertex form. So here was your original function, f of x equals x squared minus 6x minus 4. Remember, we did completing the square back in section 1.4, and I showed you that crazy Taylor Swift video where we make the blank space. So this is what we're doing here. We're going to take the x squared minus 6x, leave a blank space, shift the negative 4 over. Then you take the b term, divide it by 2, and square it. Gives you negative 3 squared, and I'm going to be adding 9 to make this a perfect square. But remember, what I added was I put it in here like this instead of putting plus 9. Now, technically, when we completed the square, we were supposed to move this constant over here to the other side of the equal sign. Because I just shifted it over, instead of adding 9 to the negative 4, I'm subtracting 9. And now I factor my perfect square trinomial, and this becomes x minus 3, as long as you remember what you got when you divided the b term by 2, that's your answer. And then now I have to add these two. Negative 4 minus 9 is negative 13. Now it's in that standard form, and look, here's my h, here's my k. I can pull it right out of the formula and get the same vertex that I did by using the negative b over 2a. Now, as far as finding your y-intercept, when it's in this form, it's harder. You have to plug in the 0. So if you were given your equation like this one, what's underneath the squiggly line, remember to find your y-intercept, you set x equal to 0, and to find your x-intercept, we set y equal to 0. Now, just to show you we get exactly the same thing, I would show you this. Now, what's going to happen is you're going to be given the equation in the quadratic form. I would pull the y-intercept out of that. Then you're going to be asked to conform it to this standard form, which finding the x-intercept is easier. So for the y-intercept, though, we're going to do y equals, make x equal 0, 0 minus 3 squared minus 13. I'm now using this function just to show you I'm going to get the same thing. So then I get y equals negative 3 squared is 9 minus 13, and I get negative 4. My y-intercept is 0, negative 4, which is the same thing I had before. The x-intercept, I'm going to set y equal to 0, x minus 3 squared minus 13, move the 13. Watch how much easier this is versus using that quadratic formula. I'm going to do the square root method, and now I just end up with plus and minus square root 13 equals x minus 3, move the 3, and now I get 3 plus and minus square root 13 equals x. So again, as order pairs, you would get this, and you would get this. So these are your x-intercepts. Let's try example 7. So here I'm just going to go ahead and complete the square. So, because that's what we need practice on. So for here, we're going to be finding the vertex, axis of symmetry, x-intercept, y-intercept, and graph it. So when you complete the square, your first step is to make sure that the number in front of x squared is a positive 1. So I'm going to divide out a negative 1 only out of my variables. So out of the x squared and out of the 6x. Leave a blank space, move the 8 over. Now the next thing I'm going to do is take my b term, divide it by 2, and square it. So negative 3 squared, and what I'm going to be adding is a positive 9. Now this is what I should be adding to both sides, but again, what I'm going to do is opposite. However, when I go to add it to the other side, I need to multiply negative 1 times the -9 that I should have added over here. So really what I'm going to do is add 9 here, and this would be the -3 squared that goes in here. So now I factor the trinomial, becomes x minus 3 squared, and then I need to do the -8 plus 9, and that gives me plus 1. Don't forget about the -1 that you factored out in the beginning, because this is going to help determine the direction of the parabola. So now we have it in the standard form or the vertex form. So now to pull out my vertex, I'm going to pull out the h and the k. So my vertex is the ordered pair 3, 1. Your axis of symmetry is going to be the equation x equals 3. I now need to find the y-intercept. Now, when you're working with both forms, you can just look right up here at your original equation, and remember, when it's in this form, the ax squared plus bx plus c, the c is your y-intercept. So my y-intercept is the ordered pair 0, -8. Now, right now, I have enough information by using my y-intercept, my axis of symmetry, and my vertex to graph my parabola. I'm also going to go back and find my x-intercepts because that is required in the question. So let me go ahead and get the vertex on here. It's the ordered pair +3, +1, which is right here. Then I'm also going to graph my y-intercept, which is 0, -8. Now, since I went by ones, my y-intercept actually goes off of the graph. So this is the ordered pair 0, -8. And again, your vertex was the ordered pair 3, 1. I can add in my axis of symmetry. So I can draw in this vertical line. Remember, it's an equation, so it's x equals 3. And now I can use that axis of symmetry to get my third point. So if I count the squares, notice the y-intercept is 1, 2, 3 spaces away. So 1, 2, 3 spaces away, and right along the same horizontal line. And then now you can connect your points. And then come over here and make your graph. Now, to find your x-intercepts, remember you set y equal to 0. And now I can use either method to find the x-intercepts. I can go back to my original quadratic form, or I could use the standard form that I rearranged. So let me just show you both. So if I went back, well, let me just go ahead and use this one. Usually this is the faster one. So if I take my equation and I set y equal to 0, I'm going to first get rid of the +1 by subtracting it. Next, I'm going to divide both sides by -1 to get rid of that negative sign in front of the parentheses. And now I'm going to use the square root method. This gives me plus and minus 1 because the square root of 1 is 1. And now when I go to isolate x, I'm left with 3 plus and minus 1 equals x. I actually have to do the math here. I have to do 3 minus 1 and 3 plus 1. And then I get, so this is what x equals. So x equals 2 and x equals 4. So an x-intercept at 2, 0, and at 4, 0. So let's come on up here, 2, 0, 4, 0. So I ended up graphing it appropriately. So this is the graph of the parabola, and then this is all the indicated information that was asked for. So x-intercept is here. Your axis of symmetry, or axis, is here. Your vertex here, and your y-intercept, and then the graph. So this is how you can go ahead and get your information by transforming the quadratic form into the standard form or the vertex form. And then it makes it a lot easier. Now you could have also found the vertex from the original problem by using the negative b over 2 times a and gotten the vertex this way also. So for example, my b value is positive 6, so opposite of that, and then 2 times negative 1 gives me negative 6 over negative 2, which gives me negative divided by negative is a positive 3. And now I take that, plug it back into the original to get the y value. So 3 squared plus 6 times 3 minus 8, negative 9 plus 18 minus 8, 9 minus 8, and I get 1. So again, your vertex, and this was all y equals. So the vertex, same vertex I got when I transformed it using completing the square. So again, when you take this test after Thanksgiving, make sure you read the directions. The question may say, using the formula negative b over 2a, find the vertex. Or it may say, transform the quadratic form into standard form and find the vertex, which is hk, from the standard form of the equation. Let's try another example. So just be able to follow directions. All right, so the next one again, it's given me in the quadratic form. So again, I would definitely pull out my y-intercept right away because I really don't need to do any work here. It's the order pair 0, 3. The next thing I'm going to do is transform it into the standard form or the vertex form. So f of x is equal to x squared minus 4x, leave a blank space, plus 3. Now, again, we should have checked to see that the number in front of x squared was a 1, and it is. So now I take the b term, divide it by 2, so negative 4 divided by 2, and then square it. And then I get 4. So generally what I would be doing is adding 4 here, but subtracting it here. Because then when I do it that way, really what I'm adding here is nothing to the whole side of the equation. Again, remember, I like to show that what I added was this, because then when I factor it, it makes it a lot easier. And then I do the math over here. Positive 3 minus 4 is negative 1. Now this is my h, this is my k. So my vertex here is 2, negative 1. So I'm going to be graphing that. I'm going to be graphing the y-intercept, and then I'm also going to be using my axis of symmetry. And my axis of symmetry is x equals 2. So by using these 3 pieces of information, I can get this quadratic function graphed. Now I'm also going to go back and also find my x-intercepts. Let's go ahead and do that now so we don't have to approximate it. So for my x-intercepts, remember you set y equal to 0. So you can use either format. You can either use the original And this one might be easier, doesn't really matter, or we can use this one. So here, if I use this one, it's f of x equals x minus 2 squared minus 1. Either way, let me go ahead and take out the f of x and put in the 0 there. So let's do the black one. This one can actually be factored, so that's why maybe using this one might be easier. Factors of positive 3 that give me negative 4, and that will be negative 1, negative 3. So once I set each equal to 0, add 1, add 3, x equals positive 1, x equals positive 3. So I have an x-intercept at 1, 0 and 3, 0. If I would have used the transform standard form, again, I would have added the 1. 1 equals x minus 2 squared. Square root both sides, plus and minus 1 equals x minus 2. Add the 2, and you end up with 2 plus and minus 1 equals x. So you would do x equals 2 minus 1, and x equals 2 plus 1. So 2 minus 1 is 1, and 2 plus 1 is 3. And again, you can turn them into order pairs. And notice it's the same that I got when I used the quadratic form of the equation. So now let's go ahead and go to our graph and graph all of this information. So I'm going to graph my vertex. I'm going to graph it at the order pair 2, negative 1. I'm going to graph my y-intercept at 0, 3. I can put in my axis of symmetry here. Again, remember it's this equation of the line x equals 2. Now, I already have my x-intercepts, so I could just plot those also. So I have one at 3, 0 and 1, 0. And again, if you want to get the other point up here using the line of symmetry, see how it's 2 spaces away here, so 2 spaces away here. So put that point there, connect, and make your parabola. Let's try one last example. Same thing. We're going to go ahead and put it into the standard form or the vertex form by completing the square. So the first thing I'm going to do is get rid of the number in front of x squared. So f of x, I'm going to factor out a 2, x squared plus 4x, leave a blank space, move the 7 over. I'm only factoring that 2 out of the variable terms. I now take the b term, divide it by 2, and square it. So 2 squared, what I'm adding is 4. Now, what in here I would put is 2 squared. But over here, you have to take into consideration what you factored out and times that by what you would be adding to the other side. And I would be really subtracting 4. So 2 times negative 4. So now what goes here is negative 8. So now I can factor my perfect square, and it becomes x plus 2 squared. And now I need to combine 7 minus 8, and that gives me negative 1. So now my vertex is right here. This is H, this is K. Remember, H is opposite of what it looks like. So that's the vertex. To get the y-intercept, remember I can go back to the beginning, and it's just that C value. So the y-intercept is the order pair 0, 7. My axis of symmetry is x equals negative 2. Let me go ahead and get these 3 points or 3 things put on the graph so we can make the shape of the parabola. And then I'm going to go back and find the x-intercepts. So again, my vertex is at negative 2, negative 1. My y-intercept is at 0, 7. Way up here. And then my axis of symmetry is this imaginary line. So I can see that this is 2 spaces away. So I'll come 2 over here, put my third point, connect them, and make your parabola. Let's go ahead and find the x-intercepts. I'm going to use this standard form. It's going to be easier. Again, I could revert back to the beginning one and try to factor it, but if I try to factor that, I would get factors of 14 that give me 8, and none of those work. So this is why I would have to do quadratic formula. So let me just go ahead and work from my standard form here. So I'm going to use this one. And again, to find the x-intercept, we set y equal to 0. And now let me go ahead and move the 1. 1 equals 2 times x plus 2 squared. Divide by 2. So 1/2 equals x plus 2 squared. Square root both sides. This ends up giving me the square root of 1 is 1, but then I get square root of 2 on the bottom. Now I can choose to either fix this fraction first because I need to rationalize it. So in order to rationalize, multiply top and bottom by root 2. So this will actually rationalize into the square root 2 over 2. This, let me just redrop down. And now I need x by itself. So move the 2. And this is plus minus. So negative 2 plus or minus the square root of 2 over 2 equals x. So again, as order pairs, it would be negative 2 minus square root 2 over 2, comma 0, and negative 2 plus square root 2 over 2, comma 0. The square root of 2 is approximately 1.4. So for example, here if I'm doing negative 2 minus 1.4 divided by 2, when I do this on my calculator, I get about negative 2.7, comma 0. And then here, if I add it, and then when I go here, I would get negative 1.3, comma 0. So let's go up and take a look at our graph. So negative 2.7. So I got it about here. And then the other one was negative 1.3. So about here. So negative 1.3, comma 0. Again, you would label these in simplest radical form. So I would label this as negative 2 minus root 2 over 2, comma 0. And then label this one as negative 2 plus root 2 over 2, comma 0. Label it in the simplest radical form. As far as graphing it, you would approximate the decimal. So that is it for the practice of completing the square, finding the vertex, the axis of symmetry, x-axis, y-axis, let's see. Vertex, axis of symmetry, x-intercept, y-intercept, and then graphing it. Be able to do all of these things whether you're given the function in quadratic form or given in standard form. Be able to manipulate it so that you can get it into the standard form by completing the square.